Hi, I'm Phil Basford. I'm Head of Solutions Engineering at an AWS partner called InnerWisdom. What we are, we're a machine learning competency partner. I'll be talking to you about how we take machine learning models and we productionize them for our engagements. Got a few slides to go through, so I'm going to skip a couple. So this is the expert track, so hopefully you all know what serverless is, but basically this is all built on the serverless architecture. So we're using things like Lambda, API Gateway, and also SageMaker. Because we're a partner, we're also looking at how we architect stuff. So a lot of this is about cost, a lot of this is about reliability, and also a lot about security, and specifically this one is particularly around operational excellence and how you can run, monitor, and observe your production workload. Now this is the reference architecture. As I said, it's a very simple service architecture. This is very keen to something we would have used in production with multiple engagements. The key in the middle there is SageMaker, but as I mentioned before, it uses other service components. Now, we're going to go really deep into SageMaker now. So, we're going to talk about the inference process. So, with machine learning, you get your data, you clean your data, you transform your data, and then you run your training job on it, and at the end of that process, you get a trained artifact. To get value from that trained artifact, you have to actually run inferences from it, predictions. The AWS endpoints is the fully managed service that allows you to do that. An endpoint consists of the actual kind of HTTP interface that you can call. And then behind that, there is endpoint configurations. Endpoint configurations have multiple variants underneath them. Each variant is basically a copy of a model running. Inside the variants, in addition to that, you have the ability to connect to a VPC, you have the ability to use KMS, and you also have to talk to S3, and we'll come on to why that is later. Now, you'll notice there's lots of words of container underneath that, because underneath SageMaker, it's all containers. So you're using Docker. So AWS provides you loads out off the shelf that you can just use, loads of open source. There's XGBoost, TensorFlow, and other ones you can use. What they actually do is they run the models, and they actually have to implement a very simple REST request and API in order to serve inferences on the SageMaker. And basically, it will load the SageMaker container, and then load in your model, your trained model artifact from S3, and then deploy that onto an instance. So, because we're using Docker, that obviously opens up a few questions. Is it using Kubernetes, ECS? How does it use the network? It works for the same problems of Lambda when you exhaust the network, that kind of thing. How does the CPU work? How do they get destroyed? What's their life cycle like? So, basically, to understand this, I conducted a series of experiments. Firstly, I trained a fully normal XGBoost open source data set for XGBoost, trained my model, and I stored it on S3. At that point, I recorded what's inside the network, so because I was using VSphere attached instances, I wanted to record what's going on. So when I was running the notebook by itself, I saw that it decreased one of the available network addresses. And then when I deployed mod 2, and we'll come to assume mod 2 is important later, we saw the other availability zones lose one address each. The other thing to note there is also that we're using a T3 instance. That had some significant impacts, and we'll come on to that as well. But in order to understand what to load and how to load, do an experiment, we have to conduct a load test. To do that, I put API Gateway and Lambda in front of AWS SageMaker because it allowed me to not have to sign v3 stuff. I could just use authentication, basic authentication for that purpose around an API key. And then I used Serverless Artillery, which is an open source Lambda-based product that would launch the load at my service. And I conducted it in two phases, a slow ramp in and sustained load period over a 2-hour period. This is what happened. This is the experiment. This is the CPU, basically, usage. So we can see the slow ramp in and then 200% CPU. So at that point, we know we're using more than one instance. We then saw something happen around 13:20. The load died down to 100%, and then it came back again, and back to 200%, and then after the final hour, it disappeared again. So we wanted to know what happened. What happened was, we looked at the log groups, because luckily SageMaker has CloudWatch logs. We only saw 3 streams of 3 log groups, and they were all labeled by instance, which meant that actually, during the load run, we only ever had 3 instances. So that's a big clue to how Docker behaves. Basically, each instance is a single EC2 instance. In addition to that, obviously something happened that we didn't expect. And then after about 5 minutes, it was brought back to normal load. Upon investigation inside the logs, we didn't actually see that there was no critical errors that happened at this time, and no obvious signs of problem. What we did do is get an email from AWS support. This stands up on the Hall of Fame. Basically, we were using those T instances, and at that point in time, basically our T instance got swamped and used up all of its available balance. So those who know T instances, you incur a certain amount of credits, and then you spend them. And basically, what happened was that it failed at that point to respond to a keep alive. Therefore, SageMaker killed it for us and started a new one. And those 5 minutes was the EC2 start and stop time. Upon further investigation and looking through the logs, we can also see a bit more what SageMaker is actually doing and what XGBoost is doing underneath. So we have established that it's 100% Docker at this point, and beyond that, it's using Geon and a couple of open source libraries to implement the model in Python and then serve inferences. The key here is that it will only start a certain number of workers, so you have to be very careful about making sure that you're using the right instance for the machine learning model you're using. In addition, that has to be corresponding to the error rate, because sometimes as you max out CPU on your machine learning models, your accuracy will actually degrade slightly. So when you're deploying in production, I would strongly advise that you conduct a series of load tests to make sure that you know what you can handle. So luckily, there's a way around this. Auto-scaling. So when I looked at this, I didn't realize, and we discovered that SageMaker actually supports application auto-scaling and can be a target group for your scaling. What does that mean is that we can get beyond the problem of having just 2 instances. We can have many instances, and we can scale them up and down elastically with your load. And the other thing is that 2 instances is important, because if you think about those long times to start up and stop, in a production workload, what you don't want is for your one instance to go down and you have no other instance to fill your load, because you will have a degraded service and an incident on your hands. So if you're doing a production workload, always use 2 instances. The important thing also is the initial instance count that we originally set in this situation turns to desired count, and you have a min and a max. So it behaves just like any other application scaling group. The other thing is there is a CloudWatch matrix, which is the number of invocations that each model will respond to. Now, during your load testing and your detailed analysis, you want to come up with a figure that you know what is the number of invocations your instance type will support, and scale on that. So rather than CPU or memory, scale on that. Like you would do in other situations when you have SQS queues, you'd scale on the depth. The same thing here, scale on the number of invocations. So that's how to cope with scaling and elasticity. The other thing to note, or the other thing to address when we think about operational excellence, is how we can actually monitor this stuff. Now, luckily, CloudWatch and SageMaker are fully integrated, so you get loads of lovely CloudWatch matrices around your endpoints. So you should set up CloudWatch alarms that monitor your endpoint, that alerts you on things like this CPU, memory, and disk. In addition to that, you can also monitor the number of invocations. So that's really good if you suddenly see an increase, or in fact, if you see a decrease. So therefore, you might have a problem with either somewhere else in your architecture, or maybe the thing that's invocating your service has had a problem. Top tips when doing CloudWatch matrix and alarms is make them complement each other. So if you have something that's high and low, the low should listen to a missing data point, the other one should ignore it. Also, make sure you level your alarms. Generally, you want to be alerted as early as possible that something is going wrong. You don't want to reach the critical threshold. So we tend to put in a warning threshold, this CPU, etc. Now, to show you what you can do is that how we made this reusable, I took it into CloudFormation, because SageMaker endpoints are fully usable in CloudFormation. So this is a CloudFormation script I wrote. Basically, it loads in all the appropriate images for Docker at the start, based on the recipe you provided, basically if it's XGBoost, if it's TensorFlow, etc. And then behind that, it does the security concerns. Thank you. And then we can see that we're deploying the model there. And then it sets up the endpoint configuration. Then it sets up the endpoint itself, and then we can see the sort of setting up of the auto-scaling group and the corresponding policy. And then below that, we can start seeing a number of CloudWatch alarms that are all pre-configured. Now, there's obviously also some things that are missing in terms of CloudWatch matrices. One noticeable thing is around API gateway. When we discovered that using access keys and usage plans, there's no actual matrix actually in CloudWatch for days today. So we used Lambda and a CloudWatch schedule on a daily schedule to put out those and put also additional alertings around them, because what we didn't want is our API to die silently to 400 errors and for the system to not respond. The other thing really good to do with some of these CloudWatch alarms and alerts is to put them into a monitoring dashboard. So that's to give you all of those live information about what's happening. That allows you to understand and respond to stuff and to know where your peaks and your troughs are, and that you can also spot things early. So I'd encourage everybody to use CloudWatch dashboards and set them up. The other thing we did, which is really cool, we used X-Ray. So X-Ray is an application monitoring tool that observes your code and any downstream services. This was important because in the reference architecture, we were looking to get below a 200 millisecond response time. We started off with 2.5 seconds and we had to crunch it down. So to do that, I used X-Ray, embedded it in the Lambda, and we've got traces inside SageMaker, and we were able to then analyze it, break it down, sort out areas of high bottlenecks and high areas of contention in the code. To do that, X-Ray is really simple. In a Lambda, who's ever used it, you basically download the appropriate SDK for a language, this Python, and then you monkey patch your code, which allows it to run over the top of the standard SDK and some open source SDKs. The other really neat feature about it is that you can annotate your code. And by annotating around your own functions, you can see how long they are taking to do some processing. What it does is allows you to have a complete picture of where your code is executing, the downstream services it's taking, and any other elements that are attributing to the response time. And you can go through each one and make sure that you're calling it appropriately, you're reusing connections, and everything is optimized as much as possible inside your Lambda. The other great feature of X-Ray this year is that it announced, and I've only just played this, it announced analytics, so you can see the distribution of response times and drill into certain scenarios. That's another way of getting a good feel to your production workload. And for this actual workload, we managed to get it to about 130 milliseconds at the 90th percentile. The other thing we were concerned about is how we deploy it. And that's another thing that people don't think about with machine learning, is how you can deploy your models, make it repeatable, control it. So there's actually 4 deployment options of SageMaker, if you strip it back, and use a bit of creativity in the process. One of them is the default, which is fully. So what it will actually do in a full situation is when you deploy an update, it will start a new copy of a new model on a new instance, and then terminate the old instance once the traffic's moved over. So that's how it's default situation. You can also do canary using the variants. So again, I said there's many variants. So what you can do with a variant is isolate the amount of traffic you want to send to that variant. So if you've got a new model, a new theory you're testing, you can send 10% to one variant, the rest of it for another. The other thing to do is you can actually do Bluegreen deployments, and I did one of them the other week. It's basically, because we cloud-formed everything, we can actually deploy it twice, run 2 copies, update 1 copy. Using the Lambda, we can switch which copy it's using an environment variable, and then when we're happy, we can kill the old copy. Or, if it doesn't perform how we wanted, we could switch it back again very quickly. So Bluegreen's also supported. Now, also as a concept, you can also do linear deployments. Again, it uses the variant option where you can proportion your traffic and then over time use something like step function to increase the traffic to the variant. You can also fully CI/CD your process. So it's like treat your data like code. So in this situation, what would be landing into S3 would be a new training data set. In response to that, we'd fire out a code pipeline that would run for a three-phase process using step functions. First one would be take that data, do the cleaning and everything that we did as part of the manual process and prepare it for training, conduct the training. Then the next step would be to take your trained model, run a batch prediction over it, and score your golden data set. Basically, your known good to make sure that you know what your tolerances and your thresholds are, and it's performing as expected. Then finally, once you've completed all that, you can then do your rolling or whatever kind of deployment you want to into production. SAM. So under the bonnet, we also use SAM a lot. Who's heard of SAM here? Yeah. So we write all of our serverless architecture where possible in SAM, all the Lambda functions, API gateways. That way, it also helped us X-Ray. We could just build and deploy consistently the Lambda functions that are used in the inference process. In addition to that, it has some really cool features. So you can use SAM Local, which is an open source project, which allows you to run it locally. That allows you to basically make changes quicker instead of having to zip and upload to Lambda. You can, Lambda on AWS, you can just run it locally, and when you're happy, package it up and actually deploy it consistently. In addition, last year, there was the VS Code Toolkit announced. So what you can also do with that is that you can, if you configure it, you can then actually debug your Lambda locally. So that really helps to cut down the time it takes to get code out the door and also resolve problems.